All right. Test review number 11 for logarithms. All right, let's get it. So the first thing we want to go over is the basic converting between log and exponential. Right? It doesn't matter which one you start with. So log of some base call it y equals x. All right, so this is typically the log shape, right? B is the base, y is the argument, and then x is the solution. You can convert back and forth between log form and exponential form by taking the b, raising it to the x, and this should equal whatever the argument is. Now, x and y could be anything, right? They could be equations. They could be anything, honestly. B, however, can never be 1 or 0, right? So these guys right here, the base and the argument, those can never be 1 or 0 or negative. But one of the tricks is that for me, when you're in the log form, it's always b raised to whatever's out here, and this needs to equal the argument, right? I've burned this little loop into my mind, so that helps me with converting. Now, whatever method you use, feel free, but just know that it's the base raised to some power equals the argument, and it's the same going from exponential to logarithm, like back and forth, right? So let's see some examples. So number 1, here they're giving us, so this is going to be 4, right? That's the base, raised to the negative 2 power, and it equals 1 over 16. All right, so using our little form, hopefully you have it written down. Always feel free to pause the video and try to see if you can answer or come to a solution, even if it's wrong, before me. So log base 4, this is going to be 1/16 equals negative 2. And we just check ourselves real quick, right? Like 4 raised to the negative 2 power. Does this equal 1/16? Yes, it does. It's exactly what we wanted. 4 to the negative half or negative 2 power equals 1 over 16. All right. You don't necessarily need the arrows. I just put those there so, for my own personal checking. Let's try another one. And this one we'll have our little rule in sight. So here we have the base 1/3, the power negative 3. It equals 27. So all we're doing is rearranging the pieces. Log 1/3 the argument is going to be 27 equals negative 3. So we check ourselves real quick. 1/3 to the negative 3 power. Does this equal 27? Yeah, it does. Okay, so rearranging from exponential to log. So let's go the other direction. Let's start with the log and go to exponential, just the other direction. So number 3, again, see if you can pause the video and See what you come up with. But the answer is going to be 9 raised to 0 equals 1. 9 raised to the 0 power. This equals 1. And actually, that makes sense because anything to the 0 power is 1. So 9 to the 0 power, that definitely equals 1. All right, number 4. Again, the base 2 raised to negative 3. This should equal 1/8. So 2 to the negative 3 power equals 1/8. That is this logarithm in exponential form. All right. So that's converting. Next, we're going to condense the logs down into one log. So we're given multiple logs. The basic rules are, so let me write those down. So the basic rules are going to be log m plus log n. This is going to be log m n. So what I'm saying is when you're adding logs together, this means multiply. Multiply what? You multiply the arguments, m times n. Okay. When we have, say, subtraction, you're going to divide. So when it's minus, this is divide. Divide what, you say? M and n. So n by m. So here's the key. The one that's to the right always goes in the bottom. Right? N always goes in the bottom. You work from left to right. And then the last rule is that if I have some sort of number or anything really in front of the log, well, that's just the exponent. So this a is really the exponent. And it goes right here. So these are the 3 rules that we're going to be applying. So let's see. Number 5. Log 42, so base 7, 42 minus brackets log 3 plus log 2. All right. So here, the brackets are basically parentheses. This negative is going to have to distribute. So when we rewrite this, it's going to look like this. Log 7, 42 minus log 7, 3 minus log 7, 2. Okay. The thing I notice is that it's minus. So when we're subtracting logs, we have to divide. So ultimately, these guys are going to go up underneath 42. So what I'm saying is log base 7, 42 over 3 times 2. 3 times 2 is 6. All right. So let's say you don't believe me. Let's just say for the sake of argument, you're like, bro, I don't like this. All right, that's cool. Here's something else you could do. PEMDAS, right, says you always do parentheses first. So let's not distribute. Let's say you didn't even think about that. Most people wouldn't. Well, here, this is a plus sign. So this means multiply. So this is going to be log base 7, 3 times 2. 3 times 2 is 6. All right, in front is still minus. Log 7, 42. So then if this is minus, this means divide. And I'm going to divide 6 under 42. So log base 7, 42 divided by 6. This is probably a little bit better, maybe. Log 7. So 42 divided by 6 is 7. All right. If you can get here, to be quite honest, you're in really good shape. Most people probably can't get this far. So log base 7 of 7. We're at the answer. This is it. This particular example, though, is a very specific property with logarithms. When the base matches the argument, right? Base 7 of 7, so 7, 7. It doesn't matter that they're 7s. What matters is that they both match, right? Like they're both the exact same number. When this happens, the answer is 1. Okay. I hate when the first example is always like some trick, like some kind of weird thing that happens, but you know, it happens. It is what it is. But log base 7 of 7, that's like, if you can get there, I'm happy. If you know that this equals to 1, that's even better. But if you can get to log 7 of 7, that's really it. That's what we're looking for. Okay. 6. I'm going to leave the rules up. Log m plus 2 log n plus 4 log p. Okay. Something else that I'm not mentioning is that the bases have to match for this to work. It's a long level course, so they're going to match. Let's just be honest. They're going to match. So I wouldn't worry too much about that. That's why you don't hear me saying the bases, right? Okay. The first thing you want to do is always move the exponents up when possible. If there's an exponent, move them up. So that's step 1. Once you clear all the exponents, like moving the number that's in front of the log, the coefficient per se, move them up, and now do the things like whatever's appropriate. So we move the 2's up. So this is going to be, actually, I'll leave those there. I'll just rewrite it just so you can see it. So log m log n squared plus log p squared. Bro, it's not even a 2. Holy crap. My bad. That's supposed to be a 4. Okay. I caught it. Okay. So all we did was move the exponents up. All right. Plus sign. So that means all the arguments are getting multiplied, right? This is multiplication. Everything is being multiplied. And then final answer. We're done. So final answer. Log 3 m times n squared times p to the 4th power. Do you need the exponents? Do you need the parentheses? Not necessarily, because everything's being multiplied. But if it makes you feel better, you can put the parentheses. Or you don't have to. You don't have to. All right, 7. Tricky. Yeah, right. So the parentheses is what's making this one. So kind of like how we started the first one off. you have to distribute the 3. So this is going to be 3 log 5, 3 log 2, right? We just distributed the 3 minus 2 log 5. All right. So we got rid of the parentheses by distributing the 3. Now we look and see, are there any exponents? Yes, there are. Each one of these is going to have an exponent. That's going to be a 3. That's going to be a 3. Here's a 2. Okay, so depending on who you talk to, some people like to bring up the -2. I just like to bring up the number. It really doesn't matter, right? If you bring up a -2, you got to know that the negative exponent will bring the 5 to the bottom. But if you just bring up the number only and still know that the minus sign is division, right? Then, you know, it all works itself out, right? Like, it's all technique. It really is. So this is going to be 5 to the 3rd power. 5 times 5 is 25, times 5 is 125, plus log, what is this? 2 times 2 is 4, times 2 is 8, minus 5 times 5 is 25. Okay. We're going to multiply and then divide. So final answer, well, I don't know if it's the final answer, but the next answer, because we're going to condense it all down. Yo, what's going on, bro? Why are my 4s and 2s getting confused? Like, if you're catching this, my bad. So this is going to be, because I said 2. All right. This is going to be 125 times 8. If you have a calculator, this will definitely come in handy. 8 times 5 is 40. Carry the 4. 16, 20. Okay. Divided by 25. Right. 125 times 8, 1,000. Divided by 25. So this is actually going to reduce. So log base 4. All right. 25 into 1,000. 40. Okay. We'll leave it at that. I mean, this will probably simplify more, maybe, but if you somehow have a key, or if you check the key and it doesn't match, oh well. Like, this is a good enough answer for sure. Like, I'm not trying to go into the weeds on how to simplify this more, right? If you can get here, this demonstrates that you can multiply when you notice the add symbol, and you can divide when you notice the minus symbol. That's the point. Like, we're not trying to do extra stuff. All right, number 8. Okay, no parentheses, no brackets. There is, however, this exponent, that's going to go up. 5, that's going to go up. Put it all together, right? This is multiply. This means divide. So final answer, condense it down to 1 log. There's no base. Just, I want to point something out real quick. Notice how in all of these, there was base 4, whatever the base is. Whenever there's no number, the whole world knows that there's 10s there. But we don't write 10 ever. You just leave it blank. So this is going to be 4 times x cubed divided by y to the 5. Final answer. Multiply, divide. Good job. Okay. That was condensing. Now let's go in the opposite direction. We're expanding. We're expanding. Okay. Here you have to be very, very precise on your details. You have to realize that when the coefficient touches the variable, right, and the variable touches another variable, this is multiplication. Multiplication is happening right now. So that's where the breaks are going to be. So this is going to be log base 5 of 5 plus, do it in red, log, where'd that log come from? It's because we're expanding. So every piece is going to get a log. 3 plus another log, y, base 5, y, 2. Okay. Exponents come down. All right. So right here, right now, if you can do this, this is awesome. This is great, right? It's not necessarily the final answer because I'm about to show you something else. But if you can get to this point right now on your own, like without anyone helping you, then you're going to be all right. You can get to this point right here. Okay. Now, what you need to notice is that the very first term, log base 5 of 5, the argument matches the base. So really, this is just 1 in the front. So it's going to be 1 plus 3 log 5x plus 2 log 5y. I mean, no, it's part of the properties. It's a thing. Believe it or not, it's a thing. If you don't see it, that's fine. But just know that when they match, it's a 1. All right. Again, if you can get here, I am like ecstatic. If you can get that far. All right. If you can go one step further and recognize this part right here, then, that's even better. It's mo better. All right. Number 10. All right. A couple things happening. Some multiplication that's happening. So we're multiplying here. There's a power. And not only that, but we have division. So we're going to break this thing apart. There's going to be three separate logs. So this is going to be log 2 3 plus log x squared minus log, should be a 2 right here, base 2 y 4. All right, so we broke apart, we expanded all the things. The last step is always to bring the powers down, right? That's really a big one, right? 2 comes to the front, 4 comes to the front, right? That's a really big one. So final answer, if you want to rewrite it one more time, I guess, but really you could just leave it like that, to be quite honest. 2, 3. Anytime you rewrite, you run the risk of writing something wrong. I mean, you see my videos. Log 2 y. Final answer. Final answer. All right. 11. Okay. This says to distribute first. Okay, so I'm not sure if I agree with this, but I get what they're trying to say, right? Distribute first. Really, what you're doing is you're applying the square to each of these. I mean, I guess it is a type of distribution, but you apply the power to everything that's inside the parentheses. So the first rewrite step is going to be log base 5, 5 squared, x squared, y squared. Right? Do you need the parentheses? No, not really. But we're applying the square to everything. Okay. Now comes the expansion part. This is going to be log 5 squared plus log base 5 x squared plus log base 5 y squared. Okay. And now to move the powers. 2 goes to the front. 2 goes to the front. 2 goes to the front. Okay, I'm going to rewrite this one time. 2 log 5 plus 2 log 5 x plus 2 log 5 y. All right, again, if you can get here, great. Right? Like that's it. But there is this right here. Hopefully you caught it. But this guy is just 1. So 2 times 1 is just 2. So it basically goes away. Right? It basically goes away. So our final answer is 2 plus 2 log x plus 2 log y. All right. So that's expanding. All right. For 12 through 15, these are okay. What we want to do here is what we did for numbers 3 and 4. Right, what we did for 3 and 4. But notice in 3 and 4, they told us it was equal to something. Right? It was equal. When it's equal, we rearranged it and we were done. So here, this is going to be like, I mean, in the instructions, right? Set each expression equal to x. So even though it's not equal to anything, we can say this is equal to something, right? It's definitely equal to something. What is it equal to? So we just pick a variable. Typically we use x. And now we're going to rearrange the problem just like we did in 3 and 4. So 4 raised to the x power. Look, I'll do it like this. 4 raised to the x power. This is going to equal all of this. 4 to the 7 power. Now I'm doing this very specifically for a reason. All right, 4 to the 7 power. So now, once you rearrange the letters or rearrange the pieces into exponential form, usually x will be kind of obvious, right? What I teach mostly is that when you're doing these types of problems, once the bases match, because right now they match. So luckily for us, when they match, you kind of disregard. You don't necessarily cancel them out, but most people say that you can, right? Like the point is that the exponents equal each other. That's what really matters. And at this point, x is equal to 7. So that would be the final answer. That's what this logarithm is equal to. Now, in the coming up cases, the bases are not going to match from the start, right? Like here, from the jump, they matched. When they match, you just cancel them out. Exponents are equal to each other. Okay. In some cases, they're not going to match right away, and more work has to happen. Check it out. So here we have number 13. So we set it equal to something. I set it equal to x. Okay. We rearrange 1/5 raised to the x power. I already don't like this. This is going to equal 625. Okay, so this particular problem has two great examples. So on the one side, we have a fraction. On the other side, we just have a number. So you have to think, all right, one side's a fraction and one side's not a fraction. How do I make this not a fraction? Right, I need 1/5 to not be a fraction. And the way we do that is I can bring the 5 up into the numerator by making the exponent negative. Right? If I make the exponent negative, right, because up here, the exponent was not negative, right? It's not negative. But by adding in the negative symbol on the x, that immediately pulls up the denominator, whatever is in the denominator. In this case, it's 5. All right. Right-hand side, 625. I need to somehow write this as base 5. It's an on-level Algebra 2 course. These will always work out, right? Like, this is going to be 5 to some power. I guarantee it. We just got to figure out what that power is. So 5 squared, 25. Cubed, 125. 4. So 125 4 times is 500. Wait. 125 times 5. 6. 25. So 4. And the bases match, right? They both have 5. So from here, right, 5 and 5. So from here, we can set the exponents equal to each other, right? This exponent is equal to that exponent, right? Because we don't care about the 5s. So this is going to be negative x is equal to 4. And just moving the negative symbol, x is equal to negative 4. Final answer. Final answer. All right. Just remember here, denominator can move up by making the exponent negative. Okay. 14. Set it equal to x, right? Because we're evaluating it. Rewrite 4 raised to the x power equals 64. So think about this. 4 to what power equals 64? 4 times 4 is 16. 16 times 4 is 64. So 3. X is equal to 3. You can also look at it as 4 to the third power. And now x is equal to 3. All right. 15. Set it equal to x. The base, 1/2, raised to the x power. So already be thinking in mind, okay, we have a fraction right now. At some point, I need to make this not a fraction. So just keep that in the back of your mind. This needs to equal 32. So to make 1/2 not a fraction, we have 2, right? Because that brings the denominator up to the numerator. Negative x. Right? Negative exponent brings up the denominator. This is going to equal, okay, so 32. We need to write 32 as a base 2. Again, I promise this will work out. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 5. And we see that negative x is equal to 5. Therefore, x is equal to negative 5. All right. So when you're evaluating, if they say to evaluate, you set each expression equal to x and then just rearrange. All right. What we got next? Graphing. All right, bet. So 16. First thing you need are the parent function points. Every problem starts off this way. So the parent function points are here, 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 and here. Right. 1/2 negative 1, 1, 0, 2, 1, 4, 2. Okay. Now remember, there's an asymptote that goes through here. Right. So you don't necessarily have to graph the original asymptote. Just know that it's there. So I'm going to erase this line. But look, the parent function graph looks like this. Right, this is the parent function graph. So this is the guy that we need to move. So these are the parent function points. All right. So now looking at the equation, y equals log base 2 x plus 6. All right. So here's what you need to know. Just like any other transformation, the inside part lies. Right, that's what we say. The inside part lies. Right, like if we were graphing this quadratic, it would shift to the left 6 because x plus 6, and this is the inside part. All right, when it comes to logarithms, you have to be very, very careful because if you notice, there are no parentheses. And if there are no parentheses, then that is not the inside part, right? This plus 6 is actually moving it up 6. Watch, because if you notice at 17, right, there's a hardcore difference between 16 and 17. 17 has these parentheses, which this is definitely the inside part, right? And we say that the inside lies, right? It's opposite. Here in 16, there are no parentheses. If there were, this is where they'd be. So if there are no parentheses, that's on purpose, right? That is on purpose. So all these little red X's are going to move up 6 places. So there's 1, 2, 3, 4. And there's the graph. Domain from the asymptote towards infinity. The range is always negative infinity to infinity, all row numbers. And the asymptote, x equals 0. It didn't move, right? It didn't move. Okay, let's try it again. 17. Again, inside lies, as mentioned. So this is going to go to the right 4. Okay, so let's start with the parent function points. Here they are. So those are the 4. All of these are going to move to the right. So basically the asymptote is going to move to the right. So there's the asymptote through -4, so I'll just write that down. So any shift left and right moves the asymptote. And all the points will move left. Wow, bro. I said left and I moved it right. So +4. +4, because this is moving to the right. Inside lies. Wow. So x equals 4, because it moved to the right. And all the points will move as well. 1, 2, 3, 4. Domain is from the asymptote towards infinity, with parentheses, range, all real numbers, or negative infinity to infinity. It is well after midnight. Okay, number 18. Number 18. So let's talk about this real quick. So this is going to be to the left 3, down 2. So left 3 and down 2. All right. However, in front, we have this negative symbol. It's going to reflect across the x-axis. Okay. That's it. Those 3 things. So now, starting with the parent function points. There they are. When you're doing these, if there's a reflection, which there is, you reflect the points first. Reflect them first. Always reflect them first, and then move them. Because if you try to move them after, if you try to reflect after you move them, you might get confused. So check it out. The way this works is, there they are. These blue X's are the reflection, right? You put a pin in this one, and then you just rotate the other ones. All right. We need to go left 3 and down 2. So that means the asymptote is to the left. 1, 2, 3. So here's the asymptote through -3. And these points will go left and down. So 3. So that guy moved here. 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 Okay, connect the dots. All right, domain, asymptote towards infinity. Range, all real numbers. Okay, one more, actually a lot more. All right, we're going to reflect across the x-axis. I'm not going to write it. It's right, x-axis. We're going to move to the left 1 and then up 3. Left 1, up 3. So always start parent function points. Reflect them. So reflecting across the x-axis. There's the reflection. That's the reflection. Now, left 1, up 3. So left 1, that's going to move the asymptote to the left. So left 1, up 1, 2, 3. So there's the first one, second one, third one, fourth one. All right, connect the dots. So I know there's X's and clutter everywhere, but you got to be able to see through it. Asymptote is going to be x equals -1. Domain is from the asymptote towards infinity. And the range, all real numbers. -infinity to infinity. Okay, let's go. We're cooking. 2 more. All right, hint. First, multiply by dilation. Okay. So, what this is saying is that there's a number in front. This 2 is going to stretch the logarithm out, right? You're going to multiply. So, let's do this. Let's multiply first and then move. So, we're going to stretch by a factor of 2. We're going to move to the left 4, down 3. Left 4, down 3. All right. Originals, the OG points. Okay. I need to stretch this by a factor of 2. So how do we do that? That's the question. Okay, check it out. The first x. This is -1. Right. -1 times 2 is going to be -2. So this dot or x moves here. This is the stretching part. Okay. On the x-axis, stays the same, right? And that's because the y value is 0. 0 times 2, 0. So it stays. All right. Next one. This is 1. So 1 times 2. And then the next one, this x right here is 2, the y value, right? The y value is 2. So 2 times 2 is 4. This guy moves here. All right, so these blue dots or blue X's that you see right now, I'll make them dots. Now I don't want to make them dots because they're not the final one, right? These blue X's are the stretch by a factor of 2. Now, let's move them left, move them down. So if we move these left 4, the asymptote is going to be at -4. And now, left 4, down 3. So there's the first one. Remember, I'm moving the blue ones. Second one. Third one. Then lastly, 1, 2, 3, 4. 1, 2, 3. All right. Connect the dots. There we go. Domain. Asymptote towards infinity. -4. Range, all real numbers. Okay, so stretch first and then move. 21, the last graphing one. Okay. This is going to be a reflection and a stretch by a factor of 3. So stretch, reflect, left 1, up 4. So we're going to stretch by a factor of 3. We're going to reflect across the x-axis. Left 1, up 4. Okay, so there's mad things happening right now. Okay, let's start with the OG points. The OG points. Okay. I'm going to stretch it first in the manner that we just did, but except by 3 and not 2. So times 3. So -1 times 3. -3. X-axis stays the same. Next one, 1 times 3. That moves up. 2 times 3 is 6. Okay, so right now, the red X's that you see were the OG points, the original parent function points. The blue X's that you see is the stretching by 3. So stretching by 3. Now comes the reflection. Okay, this is going to be ugly because there's going to be X's everywhere. We just reflect them across the X-axis. Right, so the X-axis is going to stay the same, and you reflect this one up. So 1, 2, 3. Reflect this one down. 1, 2, 3. Reflect this one down. 4, 5, 6. All right. So in green is the stretched and reflected, right? That's the stretched and reflected. Now we just got to move the green dots left 1 and up 4. Okay, so left 1, that's going to make the asymptote through -1. Okay, let's move. So it's the green X's. Got to go left 1, up 4. These are going to be dots. Left 1, 2, 3, 4. Okay, left 1, up 1, 2, 3, 4. Left 1, up 1, 2, 3, 4. Left 1, up 1, 2, 3, 4. Okay, this is ugly, but it is what it is, right? This is what it's going to look like. Connecting the dots. Okay, domain negative or asymptote towards infinity. Range, all real numbers. All right, so hopefully you know how to graph. Might have to watch those a couple times. All right, to the back. All right, some of my favorite. So here, let me just show you the rule. Right, this is actually a lot easier than it is going to look by me explaining it. So if you have a log base B, actually, let's call it, well, let's stick with B. Base B, and then some argument. Right, log base B of A. All right. We can rewrite this using any base we want. Right, log base B of A is equivalent to log base whatever you want, as long as you move the B and the A a certain way. So this is going to be log base C, right? Some new base that we can make up. Typically we use 10. Log base C. Now watch. The A goes up. The lower number B goes down. So what we're saying is you have a log, base whatever, argument whatever. You could rewrite this using some new base as long as the argument goes up with the new base and the old base goes down with the new base. And then you can go back and forth, right? You can go back and forth. So number 22, watch. This is saying final answer. We're going to go there right now. So here, look, use some colors. See if you can pattern recognize. So this is log base 20 of 3. Final answer. You're done. You're done. These go quick. These go quick. Log. Check it out. Base 6 of 14. Right? Higher number is the argument, lower number is the base. 24. Log base 4 of 7. Okay. That's going one direction. So let's go the other direction. All right, same thing. 17 is the higher number. The base is the lower number. So my answer, final answer, log 17 over log 9. Too easy, right? Like, it seems almost like we're cheating. 26. So I have 2 logs. We're going to change the base, right? Just so you know, the base we're changing it to is base 10. But we don't write the 10. Right? We don't write the 10. If you put this in the calculator, these numbers would match up, right? The values would match up. So there's 5, 12. So the bottom number, 12. Top number, 5. Too easy. Too easy. Okay. 27 through 32. All right, there's gonna be some work. Okay. We're just rearranging and solving for x. Rearranging and solving for x. Okay, let me take this back. Most of these we're going to rearrange and solve for x. Others we're going to convert. So our techniques, we rearrange, solve for x. We convert to either log or to exponential. Typically you convert to exponential and then you solve for x by setting the exponents equal to each other. Or you condense it down so that you have a log on both sides, cancel the logs out, set the arguments equal to each other. If there's a base, you make the bases equal, cancel them out, set the exponents equal to each other. All right, so those are the things that we're going to do. So let's look at 27. Of the things I mentioned, there's one log. When there's one log, you rewrite it, right? You convert this. Convert 4 to the negative 2 power. This equals x. So we have to think, okay, 4 to the negative 2 power, what does this equal? Okay, well, the negative 2 power forces the 4 to go to the denominator. Right, that's what the negative exponent does. Notice when it moves it down, it becomes positive. And 4 squared is 16. So x is equal to 1 over 16. 1 over 16. All right. 28. Okay. Of the things I mentioned, rewriting this would not work because there's 2 logs. In 27, there was only 1 log. So we converted it. We just rewrote it. When there's 2 logs, exactly 2, and nothing else, these are going to cancel. We cancel out the logs, set the arguments equal, and solve for x. Okay, so minus 2. 6 minus 2 is 4. So we're going to add 4 to both sides. Oops. We're going to add 4 to both sides. So that's 8 is equal to 4x. Divide both sides by 4. X is equal to 8 over 4, which is 2. Okay, So in the instructions, it says to check for extraneous solutions. If you've never heard this before, all this is saying is that once you have your answer, you have to check to see if your answer is truly the answer by plugging it back into the log. Remember, the arguments of logs have to be positive. And if we plug in a 2, this is definitely positive. Right? 12 minus 4 is a positive number. But you have to check it for all the arguments if there's multiple logs. So 4 plus 4 is 8. Again, it's a positive number. So if you plug in your x and you get a negative argument, no solution. No solution. But here, we have a solution. X equals 2. All right. 29. Okay, so there's no log. If I rewrite it as a log, that does me no good because we don't know logs by heart, right? And we don't have a calculator technically. So what we're going to do is I want to write this so that 125 has a base 5. So 5 to what power equals 125? That's the question. 5 times 5 is 25 times 5 is 125. So 5 cubed is 125. So I think the hardest part about this section is definitely right now is looking at this problem and figuring out a game plan. Like, what the heck am I supposed to even do? Well, the whole point is that to solve this, I want to do this cancellation. Like, that's what I want to. That is the game plan, right? In the same way, over here, we canceled out the logs on both sides, right? That's the plan all along. Because once I do that, I can set the exponents equal to each other, right? But you have to be able to see that on your own. You have to. This is going to be 3x minus 2 is equal to 3. We add 2 to both sides. 3x is equal to 5. Divide both sides by 3. Therefore, x is equal to 5/3. That's a 5. Why is this so thick? 5/3. All right. 30. So again, right here, I knew that I wanted this to be a 5 because I wanted this to happen, right? You need the lowest common base. Lowest common base. All right, with that being said, looking at this, we have to say, what is the lowest common base? Now, this is where your number sense kind of kicks in, or has to kick in. 81 and 27. You have, like, 3 has to come to mind, right? Like, at this point, you got to know that these are multiples of 3. So 3 to some power is equal to 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. So 4. 81 is really 3 to the 4th power. Okay. Don't forget about the exponents that are already outside. This is equal to, so 27 as base 3. So 3 times 3 is 9, times 3 is 27. So 3 cubed. Again, don't forget about the exponents that are originally there. All right. Properties of exponents, right? When you have a power raised to a power, you multiply. So this is 3. 4 times 2 is 8. X. This is equal to 3. We distribute, right? Because power raised to power you multiply. 3x plus 15. Now, set the exponents equal to each other, right? We don't care about the bases because the bases match. This is going to be 8x is equal to 3x plus 15 minus 3x. 8 minus 3 is 5 equals 15. Okay. So divide both sides by 5. X is equal to 3. Okay. We're at 1 hour with 2 problems to go. Let's go. Okay. Ideal situation. I love this. Cancel. Right. Don't got to do anything. Right. Nothing, no little tricks. Just cancel. Right. There's a log on both sides. Arguments will be equal to each other. So this is minus 2x, negative 7, x minus 9. I'm going to add 9. So x is equal to 2. All right. We have to, specifically with logs, we have to see, does this make sense? Because when we plug it back in, what do we get? Uh-oh, I can already see it. When we plug it in, we get 2 times 2 minus 7. 2 times 2 is 4. 4 minus 7 is negative 7. Uh-oh. This is negative. We don't like negative. Arguments cannot be negative. Arguments of logarithms cannot be negative. This inside part must be positive. This side too. Right. These must be positive. Well, as long as one of them doesn't work, because right now I know that when I plug in 2, we get negative 7 right away. Does not work. This is no solution. I'm not even going to plug into the other one because it doesn't work in one of them. So no solution. No solution. All right. Last one. Okay. Here we have 2 logs. This is probably the mountaintop of the problem, right? This is the pinnacle. This is the worst that it's going to get is right here. This is the worst. There's 2 logs and a constant. So what we need to do is combine the logs on the left into one log. We combine by using, you guessed it, multiplication. So log base 6, 3x times x minus 1. So 3x times x minus 1. This equals 3. I can already see where this is going. Okay. So do we want to distribute first? That's the question. We can distribute first or distribute later. It really doesn't matter. Let's look what distributing later looks like. So then we have 6 raised to the 3 power. So 6 raised to the 3 power. This needs to equal whatever's right here. So 3x, x minus 1. Okay. Let's start simplifying because we got to solve for x. So 6 cubed. Uh-oh. 6 times 6 is 36. Times 6 is going to be, I feel like it's like 216. 6 times 6 is 36. 18, 19, 20, 21. Yeah. So 216 equals, now we're going to distribute 3x squared minus 3x. Okay, x squared, and this is a quadratic. My. I'm going to subtract 6, or subtract 216 from both sides. So we get 0 is equal to 3x squared minus 3x minus 216. Okay, we have to factor this. So if you remember how to factor quadratic formula, slide and divide method, or you could just look at it and maybe it'll just jump out at you. This right here, quadratic formula is going to work. But even better than that, all of these numbers are divisible by 3. This is going to make life easy. Having some sort of number sense makes life easy, I promise you. So this is going to be 0 is equal to x squared minus x minus, okay, so 3 goes into 21 7 times, 3 goes into 6 twice. Oh, this is nice. This is nice because what two numbers multiply to make negative 72 but add up to negative 1? So whenever you have something that adds up to 1 or negative 1, you need two numbers that are next to each other. 1 and 2, 2 and 3, 3 and 4, 4 and 5. Right? Something consecutive. Just so happens 8 and 9. 8 and 9 multiply to make 72. However, it needs to be negative 72. So one of them needs to be negative. Which one? Well, look at this number. When you add them up, it needs to be negative. So the big one. The big one. Okay. We're almost there. These numbers drop right into the factors. 8x plus 2. Or 8x. X plus 8. X minus 9. These are the factors. The solutions inside lies x equals negative 8, x equals positive 9. So these are the two solutions that I believe they are. We just can't box them. Right? Especially if this is multiple choice, know that this is going to be an option. But it's a sucker option because you have to go back and check to make sure that they are legit answers. So when I look at negative 8, when I plug in negative 8 back into the log, here, 8 plus 1 is 9. It works. However, when you go to the other one, 3 times negative 8 is negative 24. Negative 24. So the argument is negative. That means this is not a solution because we can't have a negative number. So when we look at 9, we plug in 9. 9 times 3 is 27. That's good. 9 minus 1 is 8. Also good. So here, the final answer, x equals 9. All right, guys. Is there another page? Nope. All right. So right at an hour and 15 minutes. Hopefully this helps you out. Catch you guys in the next video.